Okay, so we have covered the basics of significance testing or hypothesis testing, same thing. And we're going to spend this video doing a thorough example talking about a test for proportion, and then we will do the next video a test for mean. So these are different than confidence intervals in that we have a number that has been claimed and reported. We aren't just going in blindly trying to create a window which was a confidence interval. We want to check a number that we have in mind. In this case, it's 28%. The newspaper says 28% of high school seniors have taken an AP class, and you're going to check and see if that's reasonable. Okay, so we're going to go through this 5-step process. All right, this is not, we had PICCI for confidence interval. This is just something I made up to hopefully help you remember. If you don't want to use that, you don't need to, and you certainly don't need to write the letters WHAPS on your AP exam. This is not an official thing, but I just think it's helpful. W is for what test are you going to do. We did this with I in PICCI, identify the interval or identify the test, kind of the same idea. I'm going to do a one sample z-test, obviously. All right, and not just because that's the title of this video, but it's one sample because I have one population of Fayette County High School seniors, and I'm going to choose one sample. This will make more sense when we start to compare two samples, like what the percentage of Lexington seniors against the percentage of Louisville seniors, something like that. But for now, we just have one population, one sample. And it's a z-test because in proportion land, you use z-scores on the original normal curve. We don't have to deal with degrees of freedom like we will with a t-test in the next video. All right, so H. This is for hypotheses. And we got into those a little bit in the intro video. The claim is the null hypothesis. And in this case, make sure you use proper symbols. The null and the alternative, they are the population symbols. The claim is that P equals 0.28. All right? That's what the newspaper said. The alternative, and you have to get this from the problem, is do we think it's higher or lower or just not equal to? And in this case, we think that seems a little low. So the alternative to it being 28% is that it's greater than 28%. So what we're looking for is evidence that it's either equal to 28 or evidence against it being 28. Those are our hypotheses. These can be stated in context. It's not an absolute necessity to state these in context, but sometimes a certain book will ask you to do that. If you needed to, you would just say the proportion of seniors who have taken AP is equal to 28%, and then the proportion, just put it into words. Okay, next. A is for assumptions and conditions. All right, so this still needs to be random, normal, and independent. I was told that we took a random sample. Okay, and get in the habit of writing a little simple sentence about this. Don't just write SRS check mark. But this is to ensure that it was randomly chosen. We didn't choose all students from the same school or all of our friends or whatever. Normal. In proportion land, NP and NQ need to be greater than 10. So we need successes and failures. So our successes were 64, which means 136. I don't know if guarantees is the proper word here, but let's not use guarantees. And again, this is not a good sentence, sorry. But this is the difference between the conditions and the assumptions. The condition is it has to be independent. The assumption is that we had a sample large enough to where we had this many successes and this many failures, which is pretty much close to independent. I'm going to talk more about the difference in those two things soon, but that's why we use A for conditions assumptions. Anyway, the last one, random, normal, and independent. So we need normal. Oh, wait. Pardon me. Hope you caught that. This doesn't guarantee independence. That is the normal condition. Forgive me. Independent is since there are over 2,000 seniors in Fayette County, now we're independent. And that's accurate, I think. We have about 500 a year here, I believe. So I think 2,000 in the county is the truth. All right, so I stumbled through them, but there's our assumptions and conditions. All right, now we are going to perform the test. This is unique to this video because we didn't get to it last time. I just told you we're going to find something called a p-value. Here is how we find the p-value. We are going to find a z-score, a z-statistic, just like we did a long time ago. It's just that this z-statistic has a different standard deviation. You should see some similarities in this and your old z-score formula, but z equals p hat minus p naught. All right, so p hat is my sample proportion. P naught is my null hypothesis proportion. And then the adjusted square root, the standard error down here, is p naught times, you could say q naught. Sometimes I'll do q instead of 1 minus p naught, but this is the way that the book I'm using right now uses it. So anyway, either way, PQ is how I think of it. And this is our formula. All right, this is the z. And once we get that z, we're going to find the area under the normal curve, just like you did in Chapter 3 months and months ago. All right, so let's get to it. In this case, p hat, our sample proportion, since we had 64 out of 200, that's the same as 32 out of 100. So p hat is 0.32. P naught was 0.28. Okay, so right away we can tell that our sample is higher than 28%, but is that just normal variation? Do we just happen to be on the upper end, or is this a result so rare, so high, that it would nearly be impossible to sample 200 and get a result this high? Because as we know, the more we sample, the closer we'll be to the true value. On the bottom, we have the square root of 0.28 times 0.72 over 200. All right, all of this together is our z-score. It's not a z-statistic, test statistic, I should say, but it's just a z-score like they always were. So the numerator in parentheses is 0.32 minus 0.28. All right, so there's my numerator, divided by big square root of 0.28 times 0.72 divided by 200. Close the square root, and we should be good. 1.259, let's call it 1.26, because that's what you do with z-scores. All right, so what do you do after you find your z-score? You need to find your p-value. The p-value is the probability that if 28% is the true proportion, p-value is the probability that we would get a result as messed up as we got or worse, as far away from 28% as we got or worse. All right, so z-scores the old-fashioned way. Got 0 in the middle, got 1.26 right here. I'm looking for this area. This area is my p-value. All right, so I'm going to go to my chart in my book and look that up. Or I can do normal CDF, either one. When I look up 1.26, I get 0.8962 off my formula sheet. That's obviously not that shaded area. That's the area to the left because that's the way the chart works. So I need to do 1 minus that, which gives me 0.1038, I think. All right, so the p-value, that's the p in whaps, 0.1038, about 10%. Make sure you understand what that means, all right? Low p-values are evidence against the null. High p-values are not evidence against the null, all right? So I got 10%, and I'm testing at the 5% level. I need to get below 5% before I'm going to reject the null hypothesis. S is state your conclusions in context. I fail to reject. Remember, we don't say we accept it, we just fail to reject the null hypothesis at the 5% level. There is not sufficient evidence to conclude that the proportion, almost done, a lot of context, the proportion of Fayette County seniors who have taken AP is greater than 28%. Okay, so there's a little variety you can have. You know how we had our confidence interval sentence memorized. This one, you can have a little bit of variety, change around the order and stuff. If you go with this wording and then just make it fit your specific problem, you're not going to go wrong. Okay, so if this is real life, do I think that it's really 28%? I have some pretty good evidence that it's not. The result I got of 32%, there's only a 10% chance that that would happen if in reality it's 28. But since the question said tested at 5%, I don't have overwhelmingly strong evidence that it's not 28. All right, 1 out of 10 times I would get a result as far away as I did get. So it's not great odds, not a great probability, but again, we go with 5%. So at the 5% level is key, because if we were testing it at the 15% level, almost the 10% level would just barely miss. But if for some reason you were testing at 11% level, which you never will, you would reject it. My point in all that rambling is, even though I failed to reject it because the problem said 5%, this problem is still suggesting to me, hey, you know what, 28 really might not be the true number. All right, so you have to make your decisions with our steps, but also realize what that 10% means. We have by no means declared it to be 28. That's why we don't accept it. We just have not found strong enough evidence to reject the 28%. All right, we need to get down to 5 to make it strong enough. All right, so there's our first z-test for proportion. Follow the whaps. As with the intervals, the calculator will do this quickly, but we're going to do it the old-fashioned way until you learn it. And there we go. Young out.